Mr. Claxon's Algebra II CP class. I'm coming at you today, or right now, via the World Wide Web and YouTube, to explain to you how and why we consider two cases when solving quadratic inequalities. We kind of just glanced over this the first time, and then we get to 8.6. And in 8.6, we can see that we use this to state the domain of f of x is equal to the square root of x squared plus 5x plus 6. So we start to study these radical functions, and we need to know the domain. And in order to get the domain, you need to go all the way back to 5.8 and considering quadratic inequalities. So, you know, if we would start with something that looks like this, actually, we don't even want that f of x there. I don't want that f of x there. You know, I want a 0 there. All I want to do right now is consider where the quantity x squared plus 5x plus 6 is greater than or equal to 0. Okay? And what I mean by greater than or equal to 0, I mean where is it going to exist above the y-axis. That's what this little piece right here means, above the y-axis. Well, that would be above the x-axis, Mr. Claxon, above the x-axis. Okay? Above x-axis. That's what we're looking at right here. So, if you look at the graph of x squared plus 5x plus 6, right, it looks like this to start. I've got to zoom in on it. I see it just barely goes below the x-axis there. Remember, I only want what's above, okay? But I want to be able to see what's below, and so I can state, so I can state the domain of this, and so I can solve this inequality. If this were an equation, let's play the what-if game. Happens a lot with algebra. Happens a lot. Then we would solve it the following way. But we all know, Mr. Claxon, come on now, get real. Okay, back to the current. This is an inequality. So because this is an inequality, it's not the case, it's not that easy to where we can just say greater than or equal to, greater than or equal to. Kind of messed that up there. Messed it up again. Or greater than or equal to. Actually, it's not the case where we can do that. Okay, we wish it was that easy. And I'm going to need to go ahead and erase here. We wish it was that easy, but it's really not. Okay? So we know that we have greater than or equal to 0. Now, what do we need to do with this? We need to interpret. So I'm going to go ahead and show you what I'm talking about here. Okay? What I'm talking about is we only want what's above. I've outlined it in pink. You can see there's just a little section there in between that I haven't outlined. So it starts here at this point and goes forever to the left. I know it keeps going up and to the left. All I'm concerned about is the x value now. Okay, it's above the x-axis. This is the x-axis here. Okay, probably should have outlined, labeled, and scaled so you knew that. So you know that. This is the x-axis. Okay, I want to keep those easy points. Get that low-hanging fruit. So I only want to consider the values to the left of negative 3. Okay? So I go to the left of negative 3. We know that to the left of negative 3, okay, to the left of negative 3 means less than, and I include negative 3 in that, less than or equal to. Okay? Because I have an equal to there, I include that in there. I have to connect these with an or, because they will create this is a disjunction. The reason why it's a disjunction is because one's going to go one way, and then because they're going to point in opposite directions. So here I have to consider all values to the right of, well, probably should have showed you that down here. To the right of, you can see that negative 2, 0 is a solution. To the right of negative 2. Okay, so to the right. To the right, that doesn't even, come on, that doesn't even sound good. So greater than or equal to, that's why we consider these two cases. That's why this is the solution. Okay, this statement right here is the solution to that inequality. So hopefully you have a better understanding now of how to solve a quadratic inequality, other than me just telling you something, and expecting you to believe me.